Next feature, we can either do the hole or we can do this surface machining around the outside. I'm going to go and do the hole next. We're going to do a spot drill with a chamfer mill to cut the countersink here. I realized when I programmed this the first time there was an error in our original tool library, but I'll show you how to work through it, and we'll upload the most current version. So if you don't receive this error, it really doesn't matter because we've fixed the tool library. So we're going to go, we're going to do a drilling operation. We're going to select from our milling library. We're actually using a milling tool for this. We're going to pick our 3/8 chamfer mill. Now there was an error in one version of the tool library where this number here, flute length, was too low. It needs to match the shoulder length for this particular cutter. If in this window it says a smaller number there, here's how you fix it. We're going to go Edit Tool, and you go to the cutter data, and for this cutter these two numbers should match. Okay, and then you hit Accept. So you would just, the error was that the number in this lower box was incorrect. Let's hit Accept, and we're going to select that tool, and we're going to start off with leaving all these things at default. We're going to go to Geometry. We're going to select just the countersink. It's important on this step you just get the countersink because it's going to set the depths by default, and if you picked the through hole, you're going to drill too deep. Okay, we're going to go to heights. We're going to retract from model top. Okay, and our feed height is going to start at the top height, which is the top of the hole, and we're going to cut to the bottom of the hole. And this is, again, you got to have the countersink chamfer selected, otherwise the bottom of the hole will be all the way through the part. You'll make a hole that's too big. Okay, we're going to leave everything else at default. We're going to go to the Cycles tab, and we're going to change to a deep drilling with full retract. This is going to take this in a few pecks, and the reason is we keep breaking tips on the chamfer mill. If we go straight in without a peck, we're having problems. Okay, so we're going to go 0.06 on our peck depths, so it'll take a few pecks at that. And then our linking tab, everything stays at default. Is it okay? And we should get a countersink. Again, look at your preview. If it's going deeper than what I have shown here, you have something set wrong, and you're going to have a bad day when you machine your part. Okay, next we're going to do this drilled hole here. Now, we're going to, with the tool library we are using a 1/4 inch drill bit, but if we were to measure this feature, inspect it, or look at our drawing, it's 257 thousandths. It's bigger than a 1/4 inch. So we're going to come in here with a 1/4 inch end mill after the fact and skim the walls of this to make it the right size. Not the most elegant solution, but that's what we're going to do. If we had a smaller end mill, that would be the preferred tool to use. So, so first we're going to drill it, but the hole will be undersized. So go to drilling. We're going to select from our aluminum library, VF1. We're going to use the 1/4 inch solid carbide drill. I'm going to select that. And we'll leave the default settings for the feeds and speeds. We're going to go to Geometry, and we're going to pick the entire hole feature that we're making. So we're going to pick the cylinder of the hole. We'll pick the chamfer on one side and the chamfer on the other, and that gives us the entire hole feature. Then we're going to go to the Heights tab, and we're going to change the retract to model top, and we should be able to leave hole top at default, hole bottom at default, but we're going to select tip through bottom drill tip through the bottom. So we want it to compensate for the drill tip and go deeper so that we get a full hole. And then we're going to add additional breakthrough depth. And we're going to put in 0.1 for that. So we're going to go 100 thousandths past to make sure we clear the bottom of this hole. And that way we don't have a bunch of flash or chips, and we make sure we've got a through hole there. Okay, and we also need to make sure we don't hit parallels. So when we set this up, we got to make sure our parallels are in the right place. All right, we're going to go to the cycle. We're going to do a PEC drilling cycle again because aluminum does not like to rub against itself. It re-welds. So we want it to do a little bit, pull out at rapid, throw the chip out, then go back in. And then on our linking tab, we can leave all that at default. We're just going to leave the default 16th PECs, okay? And then we'll hit OK. All right, so our hole will not actually go all the way through the material, but when we machine the other side, we'll be left with the hole on the other side. Okay, now we're going to do a skim cut on this hole here just to open it up from 250 to 257. So it's only removing 3.5 thousandths per side. So if we had a smaller end mill, I would use an 1/8 inch and probably do multiple passes with that. We're going to use a 1/4 inch end mill. Unfortunately, because the end mill is almost the same size as the hole, we're going to get a very small move, and it is not the most reliable. Another way to make this would be with a reamer, but we are trying to reduce the amount of tooling we're using on this project. So here we go. We're going to use a 2D contour. We're going to accept the default settings. We're going to change to a 1/4 inch end mill, and we're going to accept the default settings except for the feed rates. We're going to slow those way down because we're just going to do one skim cut, and it's going to act like a finish cut, but we want to go slower because the amount the machine is moving is so little that it could squawk on us. So we're going to go 15 inches a minute. And we're going to drop our plunge and ramp feed rate. It can stay the same since it's not removing very much material. We're going to go to geometry, and we're going to select the circle that's at the bottom of the hole. Make sure the arrow is on the inside. But you notice the area I selected isn't actually the bottom of the hole. We want it to go through to where all the way through the model. So we're going to go to heights. And we're going to use model top as our top height and as the retract height, and for our top height is going to be model top. And then our bottom, instead of selected contours, which would end right at the top of the countersink on the opposite side, which hasn't been established yet, we're going to go to selection, which allows us to select the depth we want to go to. So select the bottom of the model part, and you see this dark blue plane shows up. And we want to go slightly deeper, so we're going to go 10 thousandths. Now our drill bit went 100 thousandths deeper, but that's with a drill point. We just want to go enough that we're sure to have a fully established hole when we flip the part over. And avoid significant flash of material if we have a variance in our thickness of our part. Okay, now we're going to go to passes. And typically I have this set to wear, which allows the operator to make changes based off a stock diameter tool. We're going to switch this to in computer, and the reason is there's not enough room for us to have a lead-in move with a 1/4 inch end mill doing this. If we were using an 1/8 inch, which had more room to move around in here, we would, but we're only taking 3.5 thousandths per side off. So we're going to set that to in computer, and we're not going to do any roughing passes, but we are going to do this in multiple depths. Our maximum step down is going to be 0.125, we're not going to do, we'll do one finishing step down at the bottom of 8 thousandths is fine. And what that's going to really act as is more of a spring pass for any cutter deflection. Okay, and we are not going to do finishing on only on final depth. We want to do it on each step. And we are going to, we're not going to rough the final depth. We are going to use even step downs, and islands are irrelevant, but we'll just deselect that. We're not going to leave any stock to leave. Smoothing deviation, we want to turn that on because we're doing a very small diameter, and we should be able to leave that at the default of 4/10. On linking tab, we want to make sure tool down is selected, otherwise it'll pick up between each pass. And we have to remove the lead ends. So it's going to be a straight plunge down. It's going to give you an error because there's just not enough room for it to do a lead in with only 3.5 thousandths coming off each side. All right, we're going to hit OK. And we should generate a tool path. And it will have these little tiny circles that's going to go in. Okay, and it's going to skim 3.5 thousandths off the sides to make that a clearance fit for a 1/4 inch bolt. Yeah, next we're going to cut the surfaces. Now, the little flat here on the bottom, the most efficient way to cut this would be to cut this flat with an end mill, and you come back with a ball cutter that's the diameter that results in this radius here. So if you recall, that's a 1/4 inch radius. So a 1/4 inch ball cutter cutting on center should be able to easily make that feature. Problem is, we don't have currently a end mill in our library that can cut this flat. If we had an 1/8 inch flat end mill, it could cut this pocket, and then we would come back and cut the ball shape with a 1/2 inch ball. So we're going to end up having to surface this, which takes up machine time. All right, so there's a couple different ways we can approach this, but we're going to do a roughing cut and then a finishing cut. Okay, so we're going to start off again. We're going to do the center here, and we're going to use a command under 3D, and we're going to use this command called flat. Yeah, it's something I rarely ever use for surface machining. It's only in areas where, like this, we got a flat surface that's too narrow to machine with a flat end mill that we have in our index. So we're going to follow that with a ball cutter. So we're going to cut this with the 1/2 inch ball from our library, which matches the radius on our fillet sizes of the walls. So what we're going to do is we're going to take and we're actually going to modify these feeds and speeds here. We're going to go bump up the RPM to 5,000 because we're going to be taking off a very small amount of material. And we're going to do a rough cut here. And the roughing cutting rate, we're going to leave this the same, but when we come back and do the finishing, we're going to do a little bit different speed. Okay, and then we're going to go to geometry, and we're going to select the boundary that we're going to machine. So the boundary we're going to machine is going to be a selection, and we're going to select the floor of our finger groove feature. Okay, and so the center of the cutter, we want it to go to that boundary. So under selection, we have the option to have the tool contain inside the boundary, on center of the boundary, or outside of the boundary. We want it to go to center line on the boundary in this case. So we're going to make that selection. If you wanted to do adjustments, you could put additional offsets one way or the other with this next box. Alright, so the next window we're going to go to is our machining heights, and again we're going to retract to model top, and our top height is going to be also model top, and the bottom, it doesn't really need to be model bottom because we're going to this floor here. So our bottom height, we're going to go to selection and select the floor of our feature. I'll make sure we don't get any rapid moves or anything going deeper than that. Okay, we're going to go to passes, and there's different types. Now we're going to do, on this one, we're going to do a roughing first, and then we're going to do a finishing of that surface. That way we've cleared most of the material out and don't get a bad finish on the outside of our part. So for that rough cut, we're just going to use a profile. Okay, it's going to leave a scallop in the center, but we're going to remove that with a finish cut. And this is a pretty stout cutter, so it should be able to handle it. But again, we're just clearing out some material with a quick pass before we come and do the finishing cuts. Okay, so in order to do that, we have to pick this stock to leave box. And we're going to leave 10 thousandths radially and axially. Okay, so those will be the same. Okay, we're going to leave the rest of the boxes unselected. Then we're going to go to the linking tab, and we want to make sure it stays down. And on these radius, on the lead ends, this is where we do want vertical lead in radiuses. So you can do a horizontal lead in radius, but this is a three-dimensional move. So let's leave it at 0 in lead in radius, horizontal lead in radius, but vertical we're going to have half a 500 thousandths, and then we'll have a lead in linear move of 50 thousandths. And horizontal lead out we'll leave it 0, but a vertical lead in we'll have it 5 thousandths, and the lead out linear will also be 50 thousandths. And on transitions, we're going to do a smooth transition between passes. Okay, and then we're going to hit OK. Alright, and so we just get one pass, we lead in the center, and then it comes and does a full profile. So it's going to buzz a bunch of material off, but this blue line should be offset by 10 thousandths in two directions.